Hi, let us discuss the solution of this problem. In this problem, we are told that a prime number is a super prime if it is sum of two primes. So basically, if we have something known as super prime, then it would be an addition of x and y, where both x and y would be prime itself. Now we need to find all the super primes up to n. So we would see till 10, because if we solve the sample test case for the second one, the first one would automatically be solved. Now let us start doing this. So 1 is not a prime number, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 8 is not a prime number, 9 is not a prime number, and 10 is not a prime number. So now we would proceed with the first one. Can 2 be represented as an addition of two other prime numbers? No, it can't be. Why? Because there is no other prime number that is less. Okay. Now we come to 3. So 3, we have a prime number 2 and we can't club it with any other prime number. So we have 5. And yes, if we club 2 and 3 together, then it would result to 5. That is why we have found 1. And then we come to 7. And then in 7, we can club 2 and 5 together. Both are prime. And then we can see that it can be made 7. So basically we have 1 plus 1, that is 2 itself. That is why the solution for this is 2 itself. Now we would discuss about this, but the first step in this was first to check if the number is a prime number or not. Okay, so we need to first check if the given number is a prime number or not, and then we can club it together. So given number is prime number or not, we would first solve that issue, that how to know the given number is a prime number or not. So to know if a given number n is a prime number or not is by iterating from 1 till the number itself. And if any number is, after dividing, produces a remainder other than that, then it is fine. But if any other number, okay, any apart from 1 and n, produces a remainder 0, then it is a composite number. So let us start doing that. Okay, so let us first see the sample for 5. So if we have 5, then we would divide 5 by 1, and yes, the remainder is 0. Then we try to divide it by 2, and yes, the remainder is 1, so this is fine. Divided by 3, the remainder is 2. Divided by 4, the remainder is 1, and then divided by 5, the remainder is 0. So there are only two numbers that gives the remainder 0 when it is divided by that number. So after doing that, we can see that this is a prime number. Now let's check the same thing for a composite number. So if we have 1, 2, 3, 4, 5 and 6. So first we would divide the number by 1, and yes, the remainder would be 0. Then we divide the number by 2, the remainder would again be 0, and 3 again 0, 4 it would be 2, and 5 it would be 1, and then this would be 0. So there are many numbers apart from this. So we can say that we can check this by simply using a for loop, but this would result in a time complexity of the range of the number that is given, and it can be further optimized to square root of n. Now what we can do is, this is fine, but for suppose we want to check n numbers, then it would be just be n square. So can we do better than this or not? Yes, we can do better than this by pre-processing. How can we do that? Now let us see a method that is known as prime sieve. Okay, so in prime sieve, what we do is we declare every number as prime, and then we explicitly declare the number 1 as not prime. Okay, and then we come to 2. 2 is still prime till this point, so all the multiples of 2 would be marked as a composite number. So 4 is marked composite number. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All these are composite number. Then we come towards 3. 3 is still has survived for a prime number, so then all the multiples of 3 would be marked as a composite number. 6, 9 is to be marked, 12 is already marked, 15 is to be marked, 18 is already marked, 21 is to be marked, and 24 is already marked. Then we move forward to 5 itself. Then the multiple of 5, that is 10, 15, 20 and 25. 25 is to be marked. Other than that, everyone is already marked. Then we come to 7. 7 to the 14. 14 is already marked, and 21 is already marked by 3 itself. and then 28 is out of this range. So we come towards the next one, that is 13. 13 multiplied by 2 is 26. The 26 out of this range, and then all the preceding numbers, all the successive numbers that would occur after this point is already a prime number, and the multiple of them would be outside this range. So all the prime numbers from 1 to 25 is 2, 3, 5, 7, 13, 17, 19 and 23 itself. So these are all the prime numbers, so we can safely check, and the time complexity for this is n log. Okay, so basically we can move forward with this. Now let's talk about the second scenario. So we need to find a number known as super prime. Okay, so prime numbers apart from 2 would always be an odd number, but we know that 2 can't be a super prime. Why? Because there is no other numbers less than that. So 2 is already ignored as a super prime. Now if 2 is already ignored as a super prime, then the super prime would definitely be an odd number here itself. Now if we want the sum of two numbers to be odd, then the first number should be even and the next number should be odd. Why this thing is true? Because if we club odd with odd, then the resultant value would be even. If we club both the values at even and even, then the value would again be even. So only this scenario would survive. So if we know that one number is even, then only we have one option, that is to include 2. So if we have the special number, then this is nothing, just 2 plus sp minus 2 itself, because the value of odd is nothing but sp minus 2, because this would always be 2. So if we replace the value of odd in this, then this would be sp minus 2. So now if we have this, we just need to check that if 2 is already a prime numbers, and then we need to check if after that is prime number or not. This is what needs to be done. So what we would do is, we would first check for this p, and then we would again check for p minus 2. If these two conditions are true, then yes, we have a value itself. Now let us start the implementation of prime C. What we would do is, we would first declare p of n plus 1, then we would do memset of p comma all true of size of p itself. Now what is memset? Memset is used to set the values of every element to a particular values, but you can only set 0, 1 and minus 1. Why? Because it works bit by bit. So if you want any other values apart from 0, 1 or minus 1, then you need to use a for loop here. Now we would move forward and we would explicitly declare p of 0 is equals to p of 1, and both of them would be false itself. Then we would start the iteration from int I is equals to 2, I is less than equal to n, and I plus plus. Okay, now if p of I is true itself, then for int j is equals to I multiplied by 2, j would be less than equal to n, and j plus is equals to I. What we would do is, p of j would be made to false itself. Now as this is done, we would get every value if it is prime or not. Now we would be moving forward with this. Okay, so now we would have a counter to store the number of super primes we have. Next we would start the iteration from int I is equals to 2, but I is not a 2 is not a super prime, and 3 can't be clubbed with any other number. So int I is equals to 4, I is less than equal to n, and I plus plus. Now if the particular p of I is true and p of I minus 2 is also true, then what we would do is, we would increment the value of c itself, and then we would return the value of c. Now let us do a dry run. Now let us just compile and run. Yes, let us just compile them again. Okay, now let us see and submit this. And yes, we have successfully solved this. Now let us do a quick dry run of this. What we are doing is we are declaring a value of p of 5. So we have 1, 2, 3, 4 and 5. Now 1 is already marked, and then multiple of 2 is not marked, then 3 and 2, 3 and 5 is stored. Then we would start the iteration from here. This is false, so it won't affect. And we would here, so we would see that these two are true, so only one is true. And that's why we are returning one. So that's it for today. Thank you and have a nice day.